Well, welcome. Sorry if we're just a little bit late. David, Lydia, and Fernando are from Arup, and they will be presenting about case studies in collaboration. So take it away, guys. I'll stop sharing.
Fantastic. I just gotta find the screen one. That's the one. There we go. So let me know. Hey, this looks like it's sharing. Fantastic. Well, we're all here, so thanks everyone for joining. My name is David Dekoning. I am a product manager and product director here in Arup, and one of the areas that I lead the team on is our contributions. Today we're going to talk a little bit about what Arup sees in Speckle, what it is that it brings to us. I have a couple slides on that. And then we're just going to give you lots of examples of how we've used it. And so if you're curious about what Speckle could do in production and what difference it actually makes, today's the day. So we can see the chat as things are going, so please just drop your questions in there, and we'll either pick them up as we go or after that. And so I'm going to dive in, and then I think Lydia and Fernando, why don't you introduce yourselves just at the time when you start presenting. So, all right, onward. So as I said, I'm going to give an overview, and then the case studies are going to be in mechanical engineering. We've switched up the order, so then structural engineering, design, automation, and facade, and multidisciplinary work. So there's a lot of digital stuff going on in Arup. We do a lot of work, and so I put together this little matrix of, on the one hand, data structures and algorithms, so tools to deal with data, tools to deal with algorithm, and tools that change how we work, and tools that just make our current work more efficient. There we go. And Speckle really sits on the data structure side. It's a great way for sharing data, and I've put it as a comet with a long tail, because what's really fantastic for us about Speckle and driving adoption is that it actually helps us automate the boring stuff. It has integrations with the design tools we use, and yet once people have learned to start using it and bring it into their workflows, it has the capability to turn everything they do upside down and really transform the way we do our work and the way we collaborate. So, within Arup, we focus on structural engineering, mechanical engineering, linear infrastructure, and interdisciplinary communication. That's maybe to say that these four things is to say it's a focus is perhaps not the definition of the word focus, but there's so much stuff going on in Arup that we've decided to as a first area of deployment, this is where Speckle is going to sit. Now, not the wrong version of the slide. There we go. So how do we, within Arup, we have a Speckle team to deploy Speckle. Why? It's software. When you're using software from a vendor, you just use it. You just roll it out. You don't need to have a special team for that. When it comes to open source, it's helpful to think about the whole product model. This is something from software marketing, where you have a core product, but for people to use it, you got to have standards and procedures. You got to have additional software. You got to help people change how they do their work and all that. So what that means for us in Speckle is we've got the server and the core connectors, and we contribute to some changes to that because it's open source, but we do major contributions internally within Arup and that we share externally in developing new connectors. So next week we'll be shortly, we don't have a specific date, but this month we'll be open sourcing Bentley connectors for Speckle V2, as well as the GSA structural analysis connector and a structural schema. So these are areas that we need to integrate Speckle into our project works, and we're contributing those back. And then internally, just further integrations, training, deploying it, making it available to project teams, and also tying it into their existing project systems. Across the whole industry, people are running really fast. There's a lot of time pressure. There's a lot of fee pressure. Not everyone has time to step back and say, hey, let me change this. So as the Speckle team within Arup, part of our role is to make it easy for them to adopt Speckle and gradually change. And when there is a need for a bigger change, to come alongside them and help them with that. So this is kind of how we this is a difference in bringing just a relatively young open source project into a company. Some of the things that previously were done, that you might expect from a vendor, we do that internally, and we think that that's a huge benefit because we can contribute back to the industry and we can be right at the cutting edge. So with that, I'm going to pass it over to Lydia.
Hi everyone, can you hear me? Awesome. So hi everyone, my name is Lydia. I am a mechanical HVAC engineer and energy modeler by trade, and am also involved in sort of the product management side of Speckle within Arup. And so I'm going to talk a little bit to a couple of workflows that we use within Arup mechanically, and also a bit about some changes to Speckle that resulted because of those workflows. So if you look at the top of the slide here, you're going to see kind of what constitutes a typical, very simplified but typical mechanical workflow for us. We typically start with the geometry in Revit, use that to do all of our zoning and our simplification for our load and energy models. That software then gets passed to an energy model, whether that's via IES, OpenStudio, or some other Energy Plus engine like Honeybee or something like that. And then typically we process those results in Excel. We use the Excel worksheet to size our equipment, and then all of that data gets pushed to Revit as a schedule. And sort of the sticking point of this workflow is that it is extremely linear. So if I make a change here on this step 2 of the process where I'm zoning my load model, that change doesn't get pushed back to Revit. I have to manually go back in and make it in Revit. And of course, if we were all had a bunch of time on our hands and we all were really passionate about sort of having a single source of truth of data, we would start that process over from the beginning every time we had to make a change, but a project typically just does not allow the time or the scope to do that. So what ends up happening over the course of the project is that you will have different sets of data located in different softwares, and oftentimes only the designer really knows which set of data is accurate for which area of the building, for example. So one of the things that was really preventing us from using Speckle to kind of help us out on this workflow is that typically we do trade data back and forth using spaces in Revit. And unfortunately, the functionality just was not there to be able to do that. And so we worked with our development team to get that added so that instead of having a single linear workflow, David, if you can click one more time. There we go. So instead what we have is a workflow that can go back and forth depending on what stage we are in the project. So if I end up needing to make a zoning change in my load model, it's very easy to just push that change to Speckle, pull it back into Revit, and not have to worry about making that change again in Revit. So that's what's in Revit matches my load model. The other huge advantage that this gives you is you can, instead of having to figure out where the most accurate data for your project is sorted, you can use Speckle as a sort of single source of truth for all of that data. And this makes looking at change sets for project data, figuring out which designer changed which area of a building on large projects, or even figuring out if something in your project is out of step, so much more easier than the original process of having to proceed through this very linear, not very smart or adaptable workflow step by step for a project. Next slide. So one example of a more overarching tool that's been built within Arup using Speckle that deals specifically with an energy modeling and loads modeling workflow is our BIM to BAM tool. And that's BIM to BAM is BIM to building analysis model. And this is a tool that lets us look at basic geometry and architecture within Revit, simplify it and create spaces that we use for our load models. And then we're able to use Speckle to sort of merge those spaces with the design data like occupancy, watts per square foot for lighting and equipment, or per square meters if you're not in the US, to very easily create a GBXML file with all of our sort of initial loads assumptions per space type already filled out. That can be then passed back to Speckle and brought into any load modeling software that we use within Arup. So now, instead of having to spend sort of days figuring out how to simplify a model, going back and forth along that linear process that I showed you all, we can get a load model up and running in a matter of hours, which particularly on large complex projects is a huge time saver for us and makes our workflows quite a lot easier.
Fantastic. Thanks, Lydia. And if any of you have questions about projects, and we're going to go pretty fast through all of these, please, we'll come back to them at the end, so don't worry. So this project is an example of a bunch of existing buildings that needed retrofit, and we were able to use Speckle because it was a really efficient way to have one person build the BIM model and the structural analysis model. So Revit has a capability to build an analytical model, and with Speckle we were able to ship that directly into our analysis. And so, Thibault here was basically able to save a huge amount of time. And as well, because this was a project that the team in Canada was working on, but the projects were in Europe, so the fact that it was in Speckle also helped that that coordination and that communication across many time zones. This is a project in Wales, Dolphy Crossing, and again, Speckle was used to ensure that the analysis model was in sync with the BIM model. And you may notice here that there's a whole bunch of different interoperability things going on. We start with work in Autodesk and through to Grasshopper, into Tekla, and out of that first Grasshopper, we're actually sending just parameters in Speckle. Speckle, depending on the needs of the project team. Here they're using a plugin called Geometry Gym to create the GSA model, and they're just using Speckle to transfer the parameters. But it allows them to split up their Grasshopper scripts. It allows them to get more than one person working in the parametric design at once, and it's a key component in keeping the BIM, the physical and the analytical model coordinated. Moving right along, unfortunately, I can't show you pictures of this project, but it's a big warehouse project, and we're building a number of these around the world for a single client. And this is a really cool example of how you don't have to go whole hog on Speckle to get the benefits. So in this case, the team starts with setting out geometry in Rhino. So they just lay out basic geometry of the warehouse in Rhino, and they have a Grasshopper script that builds up the structural analytical model from that in Grasshopper. And from there, they send that off to structural analysis. GSA is a structural analysis package via Geometry Gym. So far, so good. But then the team said, hey, we want to build a Revit model, and we can actually run a Grasshopper script using Rhino inside. But how do we get from our Grasshopper script in Rhino to our Grasshopper script in Revit, Rhino inside Revit? And Speckle is a fantastic solution to that. So, the team was able to pick this up and say, hey, this solves our problem. We don't have to run all of our scripts inside of Revit. We don't want to do that. We want to work in Rhino as much as we can. And so now we're working with the team and telling them that, well, actually, you can just with Speckle, you can go directly from Grasshopper into Revit without using Rhino inside. And you can also use Speckle to go directly into GSA. So if you're thinking about, hey, how do I get Speckle use within my firm, you don't need to change everything. You can take one step and say, hey, this is a cool benefit. Okay, now the team says we've got like 3 different tools. Let's consolidate. And Speckle does so much that it's a great tool for consolidating. Our infrastructure teams. I talked earlier about processes and standards are important. So our infrastructure team in Europe has set up a process for using Speckle called total infrastructure modeling. And this is a bridge. This is not a demo bridge. This is an actual bridge that our teams are designing. They're using Speckle to go from Civil 3D into Rhino. And speaking to Paul here, who gave me these images, he said, I've just started with Speckle 2, and it's really great. We've got a Civil 3D connector directly in there, and I don't need to use Dynamo anymore. And then that goes into doing some work with Rhino and Grasshopper, and then from Speckle, again, they can send it directly to Revit. One thing, if you're working in linear infrastructure and working these big projects, that I learned getting into this project is that Speckle does a better job than a lot of other software at dealing with large coordinates. So if you're working in Civil 3D or some big linear infrastructure, you're very likely modeling tens or hundreds of kilometers away from the origin, and that just passes through Speckle without a blip, without any problem. So that's really cool. And as I mentioned, we'll be releasing Bentley connectors, open roads, open rail. And what's important to that is that, generally speaking, maybe you're working in a big firm or in a small firm, and in one office, you're all using the same software. But then all of a sudden you get pulled into an enormous project. You're either working with colleagues in another part of the world, or you're in a joint venture with somebody else, and that other person is using different software. And so, what we're likely to see is that when some offices are in Bentley, some are in Civil 3D, we can actually use 80% of the same workflow because we can start from that same thing, and as soon as it goes into Speckle, it's in a common format. So for us, that's perhaps a more prosaic bit of collaboration, but just being able to share that information and maintain as much as your workflow as possible is really valuable. This is a cool project out in Ho Chi Minh City. It's a high-rise tower. You can look up Empire City MU1 and some pretty cool pictures. That sort of blob 3/4 of the way up the tower is a garden. It's very beautiful. And again, the team is keeping the analysis and the BIM model in sync by doing parametrically generating the model in Grasshopper, and then with Speckle, just pushing two streams. And they're always in sync because they always come from the same place. And so there's never really any fear of going back of, I made an update in the structural model. Now I analyzed these beams, but they're building those beams, and now we've got a huge problem. Everything stays in sync just because we're able to base everything from the same common setting out. So in addition to structural stuff, we do also have a move to the cloud, a move to automation. Arup Carbon, which is something we've talked about in the past, and we are talking with Dimitri and others about open sourcing it and getting this out. Ongoing discussion with lots of different things to think about. But what's interesting for us is that we can build one tool on top of Speckle, and we can push data from anywhere. We can push data from Rhino. We can push data from a hand calculation in Excel. We can push data from Revit, and we can get consistent, common carbon reports that we can give to our clients and we can use for internal audits. So building tools on top of Speckle rather than on top of individual tools really gives us a lot of flexibility. We've also, again, and I apologize for not having really cool pictures here, but we have some work internally within Arup on setting up design workflows in the cloud. And what's really cool about Speckle is that we were able to basically add one little component to add into Grasshopper that allows a user to say, hey, I want to run a design workflow, and they can authenticate with the Speckle server. And what's actually going to happen in the background is a Grasshopper script is going to run on Rhino Compute, and that Rhino Compute script, nowhere near your desktop, is going to come and access your Speckle streams, run a bunch of calculations, and then push back. So I said earlier, Speckle sits on the data side. This is the integration with the algorithm side. And with the new webhooks in Speckle 2, we're actually able to have someone log into this platform and say, hey, I want to run this Grasshopper script every time my data updates, and I want the results pushed to this other Speckle stream. And so as you push data to Speckle, you're able to have transformed or augmented data or coordinated data, federated data, whatever you set up, on an ongoing basis automatically. Kind of like, for those of you familiar with the software world, CI/CD, and so Speckle plays really nicely with that. And then finally, going back to bridges, this is a specific tool sitting on that platform where we are able to basically push a bunch of parameters up into the cloud, and using just Grasshopper scripts that a team, the skills are there. There's a lot of people know how to build Grasshopper scripts. We're able to now put those into the cloud. We'll run it tens of hundreds of times, and generate comparison graphs and all that. So really going to the next step is getting into these automation levels. We've taken that first step of allowing people to use Speckle to communicate, and once they're doing that, we make it available in the cloud. The same tools they know, and instead of running 1 or 2 analyses, they're running thousands. So it's really step by step to real transformation. So just gonna pass it over to Fernando now to talk about a number of other case studies and specifically about interdisciplinary coordination. Over to you, Fernando.
Thank you, David. You can hear me. And I'm Fernando from the Building Envelope Design team in Europe. I'm an architect as a background. Within the building envelope design, is very common to collaborate with a number of disciplines. As a building envelope has a role to play in the lighting, acoustics, daylight, solar performance, energy modeling, structures, and a number of parameters, right, and performance that needs to fulfill. So it's often, we are often in the middle of that sort of busy collaboration where data is produced by a number of tools and processes, and often we end up building parallel identities of the world of our project, right? And we run different models in parallel because it's just easier, right? And that often leads to like a huge effort to then merge back the evolution of the different designs from each discipline perspective. Not unusual to end up with a few 100,000 clashes on your BIM models and so on. So what I'm really interested is to the role that Speckle can play into improving the way we collaborate in the building industry. Right? So I would like to be able to engage with the sort of processes that David and Lydia have explained before, and have a dialogue with them from different aspects of the project, from a multidisciplinary view, right? This is what we also enjoy doing in Arup, right? This sort of total design where everything plays a role in a decision. So go to the next slide. I think there is also like a danger, right, on the way, on the amount of data we create these days and the difficulties, the challenge to manage and to coordinate that, and often leads to like hassle, but also to some risk and some mistakes along the journey. So following some recent tragedy in the UK, the Grenfell Tower fire, there was a kind of a point of inflection there in the industry where kind of there was a reflection and commitment to create a more consolidated data flow of information across stages and across the life asset, the life of a building, right? So we are sure we understand what are the decisions that were made, who took them, and why. So this is next slide. The role that I think where Speckle can make a change and can contribute, right? Building together not just different software packages, but also different disciplines and teams. So I'm going to share 3 real examples of how Speckle has contributed into joining a few disciplines. Right? So the first one has happened before with David. I won't be able to show you some renders, but I've put together some diagrams that hopefully you can process in your mind to understand the complexity of this. So we had this tension structure, large span tension structure that was holding a glazed roof. And tension structures tend to move differently. So if they are also subject to different geometries, span, and configurations, it can be a bit challenging to understand the behavior of that. The panels of the roof will be moving with the tension structure. The joints will be opening and closed. So it's quite critical to understand what that behavior is, because it can compromise the cells there. Next slide. furthermore, into the facades, we also get into detail of understanding how the glass behaves. So that movement may deal to warping of the glass, which again may compromise and put some stresses on the seals of the downward glacier, and it's not performing anymore. Also, the opening and closing joints can put too much stresses on the glass itself, or make the glass touch into each other and do some breakages. So, and with this sort of context, and you go to the next slide. Now imagine you have that tension structure is also support for a water feature, a massive choreography with dynamics, dynamic and changing flows of water on that roof, right? So next is what you may think what can possibly go wrong there, right? So we understanding the behavior of that to reassure the client that there's not going to be water going through and any sort of load case and scenario was really important, and having the data at hand to support that design and logic, it was very important, and making sure that data was coordinated across different parties was key, right? So just to add to the before, right? So from our perspective in the facade discipline, would be studying, understanding, exploring different support strategies and how and what the implications are from the different movements. So in the next slide, you can see that rather than developing models in parallel and then trying to bring everything together, we work out a seamless data flow to collaboratively build a model of principles, design principles that help us coming together with a coordinated response to the project. Architecture was streaming a number of iterations of the geometry to both the structures and facades team. So the structure engineer could take that sort of initial panelization to inform and optimize the shape of the tension structure, and also then stream into analytical software to understand the deflections, movements, applications of the nodes in the tension structure. You select then the information from both the architects and structures will then stream to the facade team. As you can see there, right? So we were building a parametric model of the secondary structure and glass between the architectural and structural layers, right? And every time someone was playing with architect was playing with the geometry, that will pass through the structural scripts and then come back to us and get our model updated between those two disciplines. Then we could then provide feedback, insights to others on what things work, or to also others could do more detailed calculations, right? So we can build on this sort of loop where we are refining the design. Next step, that's the sort of the feedback, and finally we be thinking collaboratively building some of the deliverables together, right? Rather than having two and then trying to combine them. So you go to the next one. That's sort of an idea of the sort of model of principles where we started very basic, communicating to each other the minimum amount of information that was needed for other disciplines to build the work on top. And we use those objects also to stream relevant data that was important to understand again the behavior of this structure. And the next one, you can see how we were then sort of building this sort of step, right? So from an exploration step where we are building those design iterations and load cases, and that we will then evaluate to understand behaviors and how movements are accommodated, and finally use to build complexity. So that's that sort of common model of principles will be for each discipline to start adding complexity to the deliverables. In the next slide, you can see also an example of how can team be a collaborative deliverable as well, right? You could have one team developing some models and other team making some analytical calculation to inform the sizes and dimensions of the elements in that model. So there you see like how adaptive components were placed on the position and were shaped to the dimensions that were driven by orders. Right? In the next slides, you can see then another real project. This time is it's something in the UK. So it's the Hs2 Interchange Station. It was the first railway station in the world to achieve BREEAM Outstanding Achievement in design stage. And part of that was this sort of ambition for bring together all disciplines to make the right solutions, to fine-tune all the parameters to make sure that one, we could deliver a station that relies on mechanical ventilation, that all the parameters to make that possible, solar gains, daylight, airflow, and so on, were sort of fine-tuned to work with that strategy. But also that we could control or have enough reassurance on the internal conditions to make sure like the timber structure would survive over the service life of the building. So in the next slide, you can see again another workflow where you can see where there is a number of tools, scripts, and processes to define a design logic, and that then Speckle was used to allow that collaboration to stream relevant data to some of our analytical tools, whether it's energy modeling, solar analysis, structural design, CFD, to be able to iterate our solutions faster and come up with a common solution, right? That is already coordinated, and that thanks to this sort of iterative process and more responsive and dynamic process, we can sort of reach or fine tune or refine faster. And the next one, to end up with something a bit more enjoyable, is it's a sort of small project, it's a sculpture. You visit London office, our London office a couple of years ago, you may have seen a robot pushing pieces of aluminum sheet to be shaped into these sort of ravioli modules, right, were then assembled together during the exhibition. This is using digital fabrication, a technique called incremental sheet forming, where a robot little by little kind of pushes the material to shape it and to turn a relatively weak metal sheet into a 3D shaped component that, while some areas will have lost some thickness, the 3D nature of it will sort of bring some additional strengths, right? So in the next slide, again, you can see a workflow of that. On the left-hand side, you can see how the team were trying to explore analytically and empirically the behavior of this technique and how the material and the manufacturing process works and behaves. So then we could then extract what are the logic of that we can push into the design logic, right? So what have we learned from the analytical empirical experience or process to then sort of turn that into an input for the design. If you go to the next slide, then in that case, I'm highlighting the structure model on the top left and the module depth and connection radius in the center, right? So the bending moments of the overall structure then were informing the depth of the module and the connection radius, so it could address the sort of the structural requirements at each point along the curve. So we're sort of extrapolating bending moment and turning that into a design parameter, and it's Speckle to build that sort of connection, right? So and finally, that will fit into the top image that shows the overall workflow and the successful construction. That's a sort of experimental project where we had two parts of the structure growing and coming together at the center without any additional substructure. So that was a bit an overview, right, of how Speckle can be useful for automation, but I think it's even more exciting to challenge the way we collaborate, right, and think about how can we share data rather than files to make our workflows or data flows more collaborative and dynamic. And that's all from me. David, are you on mute maybe?
What is everything all right, David?
Yes, I think that was pretty much the end of this. So I think we can open the session and see whether people have any questions, any thoughts. They'd like to share. So
Sure, sounds good. We don't have any questions yet, but we can. Also, sorry, I don't know where my camera is gone. But I can drop a question in the chat while we're waiting for everyone else. So I was kind of wondering more big picture, like what's your philosophy with introducing kind of new collaborative workflows and kind of going off of that, is there friction getting people on board? Is this done on a per project basis? And if so, how do you ensure that those lessons are carried on in future projects?
That's good questions. I think we'll take some of that. From personal experience, I think of course we are doing things a bit differently here, right? So you're gonna find resistance for sure, but you're gonna find allies as well. So it's about looking for your allies. And I'd say the advice would be start simple, identify an area of the project that can be sort of isolated somehow, or which you can find your allies and develop some interesting workflow using Speckle. Don't tell anyone until you have something that works, right? It can be used to support what are the benefits that can bring to the project, and then start growing that group of allies and see where you can take it. But yeah, it would be very difficult to think start a project, big project with a lot of people, and then starting using this sort of process from the beginning. It's a bit of a challenge. Then I think there's a bit of a journey to so the industry and the teams evolve into that direction, and that's eventually the same thing that we have a BIM execution plan these days. We'll have a data execution plan in the near future to manage that process.
Can you hear me now?
I can hear you a bit, but it was a bit laggy. Can you try speaking again? No, I can't hear anything. Can you try maybe hard refreshing the tab? See if maybe that'll clear something out. And then in the meantime, there's another question from Alexander. He asks, structural analysis robot-made structure was done in Grasshopper, a third-party application. Was it done in Grasshopper or was a third-party application utilized?
We use Grasshopper for some initial analysis. We then validated. So Grasshopper to make that sort of structure analysis dynamic, let's say, so we could feed the design. We would send our final structural solution to an analytical tool for validation, such as GSA. That's why we use it now. Right, so it's a bit of both, depending on maybe on the phase or on the stage of the process, of the design process, you may want to go. Sometimes you want speed, sometimes you want reliability.
Great. Looks like there aren't any. Oh, is there another question? Okay, another question from Thomas. Are you still using Rhino inside for interoperability between Revit Rhino Grasshopper or Speckle, now the predominantly one used?
I can share my thoughts on that as well. So I'd say they are both great initiatives, and they're very much complementary to each other, right? So Rhino Inside is super powerful. Love it. But I think it's great if you are working in a small team or with yourself, right? But as soon as you start opening this up, involving a number of people, teams, and companies into that workflow, then Speckle is what will allow you to escalate that sort of process, right? And take it not only as part of the Rhino Revit interoperability, but open it up to a more richer sort of multidisciplinary discussion.
I would say that it's a bit difficult for mechanical engineering to use Rhino inside, because if we're in Rhino, it's typically because we have to make changes that are difficult or not realistic to make in Revit. So I would say, at least for mechanical workflows, we're tending more towards Speckle than toward Rhino inside.
Cool. We've got another question from Yvonne. He asks, what will be your considerations for developing a web app on top of Speckle, like the Carbon tool, versus using third-party software? David, I see you moving, but I don't hear anything.
That's a perfect question for David.
I know, right? Oh no.
Let's give him maybe a minute or two. Okay, it may have to do also with how many times you're gonna use that workflow, right?
Shoot. Yeah, I guess so. I would say I think the thing from a PM perspective or from a project manager or contract perspective that makes it more appealing is that we have our own Speckle servers. Whereas if I'm running something on a server external to Arup, which is essentially kind of what the cloud is, right? Depending on the project contract or some of the things that you're working with, there might be some sort of data privacy or data access concerns. Whereas if we have control of that process, some of those things go away. And it also kind of does depend on what type of third-party softwares there are and what those capabilities have too. Like if we're looking for something that a third-party software already has, I don't know that we're very interested in. I don't know that we're very interested in redesigning the wheel or anything like that. But I would say, particularly for the Carbon tool, most of the tools that we had found were Excel-based and were not very agile. And so that for us was the reason to use Speckle, because being able to bring in the Revit model information in a Speckle stream does make it extremely more agile than it would be in an existing solution. Hope that makes sense. David will probably have more things to say if he can get his mic working.
Great. Makes a lot of sense, yeah. Oh, David's back.
Can you hear me?
We can.
Okay.
Would you like to take a crack at that question?
So I had to drop out. So I am sure that Fernando and Lydia gave fantastic responses. But really, I think the fundamental consideration for building a new tool versus using an existing tool is, can we reduce the total number of tools we have to support, and can we get people to work together? So I think that's what Lydia was saying. So we agree, and I apologize for just being repetitive. Yeah. I think we got another question for you, Fernando, now.
Yeah, G-Code was produced in Grasshopper. I cannot share much more details because I'm not the expert into that. yeah, I know it was integrated into the workflow, right? So and that's what is great, right? Sometimes if you start adding complexity into a parametric workflow that goes from concept design to fabrication drawings or files, you may end up with such a large grasshopper file, which has two problems, right? Being large and heavy, not allowing much collaboration. We're a very big team, right? So Speckle allows to involve different parties, even working with the same software, such as Grasshopper, and break up the process into a number of scripts and people for each step along the process.
Well, thank you all. I think if there are not any more questions, I just want to say thank you for the wonderful presentation. It was very illuminating to see some real life examples of collaborating, including Speckle. Maybe we can just go around some parting words and then we can start to wrap this up. So maybe, Lydia, would you like to go first?
Oh dear. No, I will say one of the things that I think there's the most potential from in Speckle that kind of like gets overlooked from a mechanical perspective is the ability to see the change sets. That's something that I think sometimes we run into things in workflows that we're just so used to dealing with that we don't really comprehend that it's a problem. And I think that seeing changes as they're made to the design is one of those things that we kind of just get used to there being some sort of lead designer or lead engineer that is going to track all of that in their head. And like, hopefully they're there for most of the project so that you know what's going on when the project hits CA. But unfortunately, that's just not the case. And it also does make things very uncertain in the project if that person ends up leaving. And it's difficult to see where things came from and get people onboarded. And in talking to mechanical engineers about Speckle, that's been the thing that once they realize that Speckle can do that for them, that is the thing that like, oh yeah, that is a huge problem. And that is something that this could help with. So I think, like, yes, Speckle is very great at handling geometry, but geometry might not necessarily be like the key driver for people in mechanical engineering to adopt Speckle, to be honest, because most of our geometry is already in Revit and we're not responsible for building geometry in our discipline. So I will just say that like the geometry capabilities are great, but I think there are a whole bunch of other side things that can also really benefit from Speckle being used.
Closing thoughts?
Most of what they think, right? So I think again, Speckle as a challenging the way we collaborate, great amazing tool. I think we are at the very beginning of a journey of change, right? We probably don't. We are not aware of all the challenges that this brings, right? And we have to bear and go through the process. And as Lydia mentioned, right, I think one of the challenges like bring visibility and clarity of how all the data is structured, not just so it's not just understood by the people who build the data stream, but others can then very easily take over, review, approve, and we start bringing more senior people into the process as well by maybe communicating that in a better way. So it's not seen as a sort of like an informal design process, but it's also well embedded into the formal process. So it has also like a level of or process for assuring the data that is traveling across the Speckle universe, right? So again, as we do in real life, we need to have someone to be able to follow up, be able to follow our work, and approve it. And then I think if that is facilitated, then I think also all this way of working will be seen as a much more mature and reliable. So auditing, yeah. And yeah, so very glad to remember, Speckle is one of the important tools for collaboration. Then the other important thing for collaboration is like go to the pub and hope to see you there tomorrow if you're in London.
Great.
The magic happens.
Yes, and so I just want to say thanks for everyone who's listened in. If you have questions, hit us up either through Hopin today and tomorrow, or you can find us on LinkedIn. Speckle is exciting not just because it's new and exciting for tomorrow, but it has the opportunity to transform everything while being useful for delivering a project today. So if you're looking to introduce change to your company and say, hey, let's do it this way, it really is. You can come in with the thin end of the wedge and then expand and really help people get on board. So super exciting tool, and we're excited to be around there. So thanks again.
Thank you very much, Fernando, Lydia, and David, for the wonderful presentation and the conversation. Yeah, thank you. I'll see you guys around the conference.